Hi everyone, my name is Akshay Iyer and I'm going to be presenting my findings for Lab 1. The idea of this lab was to build on our existing notion of an electric field and show how we can perform charge calculations with everyday objects like Scotch tape. We saw that if you peeled one piece of tape across another, you can give the tape a charge. Also, we could visually see how charged objects behave. For example, when you put your hand, a neutral object, close to the tape, there was attraction because the charge on the tape formed induced dipoles on your hand and the opposite charges from the dipoles in the tape were attracted to each other. In the last part of the lab, we conducted a floating tapes experiment which we used to determine the charge on the tapes as well as the number of excess or deficient electrons. As you can see, we have a couple pictures that illustrate what we did in this lab. The physical principles involved were, number 1, neutral charges attract both positive and negative charges. Again, we saw this when we held our hand close to the tape. Number 2, like charges repel and opposite charges attract. From rubbing a pen on hair or on cloth, we could determine the charge on our tape since the pen was negatively charged. In my case, I found the charge on the tape to be negative since there was repulsion. Another physical principle was that depending on how electrons are transferred or removed from atoms, objects can acquire an excess or deficiency of negative charge. In fact, we calculated this from when we did the floating tapes experiment. And the final physical principle involved was Newton's third law of equal and opposite forces. The reason that the floating tapes part worked is that the upward repulsion force from the like charged tapes was equal and opposite to the downward gravitational force. So here's a quick summary of my results. The tapes used were 8 inches or about 20 centimeters. Both the tapes I found were negatively charged. The mass on each tape was about 0.2 grams and the separation distance for the floating tapes part was about 0.016 meters. Since we have the mass of the tape, we can find the magnitude of the force of gravity. We're going to need to convert the grams into kilograms and multiply by 9.8 meters per second squared to get the newtons. Because of Newton's third law of equal and opposite force pairs, we can now find the electric force on tape B, which is the one floating, and that's going to have the same magnitude of Fg. This allows us to use the equation K times Q squared over D squared, where Q is the charge on tape B, to find our Q value. And doing the math, we'll get Q to be around negative 7.4 times 10 to the negative 9th. Charge on B is going to be negative since both the tapes are found to be negatively charged. Now that we have our Q value, we can also work out some more interesting calculations. Dividing the charge on the tape by the charge on an electron will give us the excess electrons. We can also compute the number of atoms on the piece of tape, which we got by taking the surface area of the tape and dividing by the cross-section area occupied by one atom. Now finally, we can find the fraction of atoms with excess charge, which was only about 1 in 92 million. These calculations, however, rely on a few key assumptions. We assume that each tape had the same net charge and each charge is located at the center of the tape. Also, we're ignoring any air resistance that may have factored into when tape B was floating. To create a computational model of the lab, we use the function from lab 0 to determine the electric field at an observation location that is at the center of tape B. We can then use the formula F electric equals Q times electric field magnitude and try different values of Q until both Fg and F electric have the same magnitude. The computational model is really just an application of the physical principles discussed earlier. Comparing the magnitudes of Fg and F electric is just Newton's third law of equal and opposite force pairs. In fact, when we calculate the electric field, which is kind of a virtual force that acts on charged particles, we can do this because the tapes are charged as a result of one of the physics principles discussed earlier, which is that objects can have an excess or deficiency of charge through exchanges of electrons. One thing to think about is what if electrons were positively charged and protons were negatively charged? There won't be a difference in observations, however, because like charges will still repel and opposite charges will still attract. It's also really important to minimize contact, as neutral objects or positively charged objects could effectively neutralize the tape and the floating tape effect just won't be there. To wrap up, in this lab we were able to determine some interesting properties of charged objects relying on a couple physics principles. It's really important to study properties of fields and charge because of their widespread presence in our daily lives. Alright, so that is the end of my lab 1 video. Thank you guys for watching.